Welcome back. This is Justin. This is going to be Lab I, and for our first task, we're going to be going over converging lenses. So, first method that we use with our converging lenses is using the parallel arrays method, which is going to be finding the focal length of our converging lens. So the way we do this is we have an object set up, which is going to be a window with our converging lens, and then we're going to bring a screen closer and closer until an image is produced on the screen from the lens. So as you can see, the little window's actually on the piece of paper, which is great. So we're going to continue doing these methods to find focal lengths. And then here's our pretty little window that we were using for this method. Okay, so our next method is actually going to be using the thin lens formula. So what we have is we have our optical bench set up with this object, which is going to be our light source, with an image on it. So as you can see, that would be the image that's going to end up being produced that we're going to use as our quote-unquote object. And from there we have our converging lens and a screen set up on our optical bench all together. And what we're going to do is we're going to vary the distances between all these three objects and then measure the distance between the three of them when an image on the screen is produced, such as like right here. So we'd measure the distance between all these objects because there's an image produced on the screen right here, as you can see. It might be a little out of focus, but you can kind of see a little outline of it. Then we'd move on to our next method dealing with coincidence, which involves using a mirror. And what we'd end up doing is we'd set up our light box that we've been using for our object along with our lens and then a mirror. And what we'd do is we'd actually take a screen and put it right next to the lens in order to find where an image would actually be produced from the reflection from the mirror. And then we could actually measure the distance between the screen and the lens to find the focal length yet again. So as you can see, an image is produced on the screen, even though it's kind of fuzzy, but that's our next method for coincidence for finding the focal length of a lens. So our last method involves using the conjugate foci, where we'd have our screen and our objects set in a fixed location, and we'd be moving our lens around to find where two images are formed on the screen. So we'd measure the distance where the first image is formed, and then we'd move the lens around until the second image would be formed, and then measure the distance between all the objects then in order to find the focal length of the lens, which is pretty similar to the other tasks we've been doing, which is great. So as you can see, there's the image on the screen when it's bigger. And then we move on to our final task, which is where we deal with the diverging lenses. So, as you can see, we have our converging lens set up so an image is produced on the screen. And then what we're going to do is we're going to take our diverging lens and put it in between those two. And then we're going to move the screen out in order to find the distance in which a new image is produced. And from that, we're going to end up finding the focal length of the diverging lens by this method. So as you can see, I move the screen outwards, and then an image is very, very clearly produced from the diverging lens, which is exactly what we wanted. So we can measure the focal length via this method. Alright, well, that's going to be the end of the lab I, and it's also going to be the end of the labs for this series. So that's pretty much all I got for you. I wish you guys the best of luck on this lab, and whatever the future has in store for you. I hope you enjoyed these videos as much as I have, and found them useful. So thanks so much, and bye.